So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 118 and in this video we are talking about pointers. At least we start to talk about pointers. So first of all, what you can see here on my screen is that what you already saw when I try to explain references, and we will make a fast recap because we need this for pointers, because they say references behave similar to pointers, which means if you understand all these references and these memory addresses anyhow, then you will understand pointers very easy too. So let's make a fast recap. So I created here a variable, I assigned a value in, and then I make a reference. Here I created here a reference variable and then assigned this value, this variable here as its reference, which means they are connected now. And then I use this new address of operator, which we talk here a little bit more. And then I printed out the addresses of both, which I can make here one more time. And then we have this one, and we see they are the same. But careful. Oops. When I say they are the same, let me show you this one fast too. A little bit formatting here so that we can see it a little bit easier. When I say they are the same, I mean when the program starts to run, then they will be the same here at this line. But when you stop the program and start it again, then this line and this line will change, because behind the scene, the operating system and the compiler try to find storage for this variable, and it is not all time the same place. That's why all time when you start and stop your program and check after the start again, the memory address is a little bit different, and we dive not too deep in this one here, but you should know this. And but still, the memory addresses when you started the program is all time the same when you use a reference here, and that's very important. So with that said, we go back to my diagram, and you can see this diagram I have talked about it so much, and let's go fast over it here. I created this variable here, what I wrote here on top. And then I created fasted. I said, okay, when we create a variable, we start with a memory address, because behind the scene, the compiler will try to find for us a memory address, which means here at start it sees int. Int means how big the how big the memory address should means how big the storage should mean, and int is at least 4 bytes, so it will try to find a storage place 4 bytes long, so you can put value which is 4 bytes in it, at least 4 bytes, and it reserves 4 bytes at least. And then you can, after it finds this place here, it will assign it this memory address and will check, I found a 4 byte long address at this memory address here, for example. So it will to mark it. And after this one, then it says, okay, what have you more? It's I say, okay, I have created a variable name and I have assigned a value it. Okay, it will say then, let's start with the value. It will say, okay, I have the memory address with the 4 bytes long storage. You can assign your value. Sorry. You can assign your value now to this memory address, because I know you are trying to use a int, and I know that you try to use yes, our storage size, which will be 4 bytes long. You can use this memory address which I have found for you and put this value in it. So, and then I made here down as a layer which is the value, and we connected it to this with this arrow here and said, now this memory address is connected to this value. And then I created also one here on top, which is the variable name, because the compiler is more interested in working with memory addresses instead of with variable names. That's why this variable name which we created is associated also with this memory address here. And important is this arrow here, because this arrow means I'm connected now to this one as well. And the whole thing was our variable. I hope you understand this one. I tried to explain, show you something. And then the next step was here we created this reference. And I said when we create our reference, we need at start assign an already existing L value, which is most time a variable, because L value means just a fixed as a variable or anything other which has a fixed storage which the compiler can find and can assign values to it and ask and so on. And that's why, for example, a variable like I showed here, when it's created, it has a fixed storage, which is this memory address, and we can assign values to it. We can retrieve from, we can assign two values to it. We can ask for the value in it and so on. And that's why this one is called the L value. On the other side, when we compare it to this number here, which I just throw in, this one is not an L value, because this one is not a fixed value in our storage like this one here. It is not created explicitly so that we can not ask this storage place and say, now I want change your storage place, explicitly ask for variables and change it. That's why this one is not considered as an L value, which means it's considered as an R value. And if you don't know this, name's not so wild, but if you want to read about it, it's also good. But if you understand what I right now said, it's even better, because then you don't need to read much, because that's enough for starters. But if you want to get better, read in the documentation, of course, the real definition and what it means. Documentation and good C++ books, and yes, online papers are all time very good if you are able to understand them. And let's continue. So I have now here this reference variable, and I said a reference variable need at start only the reference variable name, which I have created here on top, and all other things, the address, it's not creating, the value, it's not creating. The only thing what it is really creating after this reference variable is a connection. This connection with a reference means I refer to an existing object, let's say here, which has a storage. And in this case, this arrow here says I refer now to this my telephone number, which is created here on the left side. And here is this arrow, this is very important. And this refer means I'm using your memory address, and I'm using your value, what is assigned to your memory address. The only thing what I'm not using is your variable name, because that's I create myself. I have my own variable name. All right, so why I have now repeated all the thing what we already know, and the reason for that is because I want to talk about pointers, and pointers behave similar exactly to this one. And what I mean with similar is a pointer will create a pointer variable name, and it will just create something like this connection here. And if you understand this reference here, you will understand pointers very easy, because then I don't need to explain all these things here again, what I explained for references. And I will only explain the differences, and that's it. So let's get started. So let's create a pointer. And one more thing before we create a pointer was, yes, this which we have not talked so much about this ampersand, which is an address of operator. Address of operator means I'm asking for your address. I want to know your address, and if you put it in front of a variable, it says, here, this is my telephone variable here on top, and I put it in front, and now I say I'm asking for your address for this variable name. And in this case, it would be, for example, one of this one here. And the same goes, I can ask it for a reference variable too. But when you watch closely, then there is something strange. Wait. This one is a reference, right? And this reference variable has in front of the variable also this ampersand. It's also in front. And careful, this one is a declaration, which means is on the left side. So let's say we have here left and right side. And when you see an ampersand here on the left side, it's most time a declaration, and then it means a reference. So you see this ampersand can have different meaning, and we have to be careful about this. But if it's on the right side, for example here, let's say I would make here an address operator, then it would mean you are asking for the address here, and it is already, let's see, what say initial value of non-const must be an L value. Yes, this we already learned. It must be something with a storage. So let's continue. So you understand it probably, right? So if you see it on the left side, it is a declaration. But if you would see it on the right side, of course, this is not working here with this reference value, or not. It's also not working here with normal normal variables. Then it will be asking for the address, and this address operator on the right side will work with pointers. That's why it's so important to learn them, because a pointer will explicitly ask on the right side, which is a value, as a pointer, this one. But let's create first a pointer, and then we see it a little bit more clear what I mean with that. So you have just to know this one means give me your address, not your value, your address. These are two different things. We will look this a little bit closer in a moment. First of all, let's create a pointer. A pointer is just a normal variable too, which means follows the normal declaration of variables. And let's start, for example, again with int in this case, and I call this pointer variable. So far, you see, so far it's a normal int variable. It's not a pointer. To make this one a pointer, there is a special symbol. For example, for a reference, we had the special symbol ampersand here. And for this pointer, we have a special symbol, or let's call it overloaded symbol, because this ampersand has more meanings. More meanings means all time overloading, but we can call it also special symbol here, whatever, it's okay. It's an asterisk. This asterisk is the special symbol for pointers, and important again when it's on the left side, because this asterisk can mean also multiplication. We have to be aware of it, not that you think something, let's say 4 multiplied by 7, something like that. In this case, it's not a pointer, it's more a multiplication. We will try to multiply 4, multiply 7. And we have to learn again to differentiate when it's a pointer, when it's a multiply symbol, or there is one more thing which we learn in a moment, which with this asterisk sign. This is an asterisk, I don't know, I hope it's asterisk. And then we can see what happens. Okay, let's continue. So we know this is now almost a variable creation. When you see an asterisk sign here, it means we make a normal variable to a pointer variable, and we can assign nothing to it at start. That's possible. That's interesting. But that's not true. You have still to assign something to it. Because, you know, from normal variables, we are trying to assign still a value to it. For example, 0 as a default value or start value, which will be overwritten later. And here we should do something similar. And that's very interesting because with references, we can't do this. Well, what I mean with this, if you create a reference, you need at start definitely an already existing object, which is an L value, which means has in storage. Something like this one as a variable, you can assign it. Here, on the other hand, a pointer need not this kind of stuff. You can assign, for example, always a 0 for it. And this one is called later a null pointer, but this one was, let's say, used in older versions, but this changed a little bit, but still we learn it, so we have to understand that this is possible. Then there is another thing, which is null, which means also it is null. We will talk also about it a little bit more, which means basically the same like the 0, but has some I don't know, perhaps some advantage behind the scene. We will not dive too much deep in it, just to understand, yes, it means it points to nowhere, something like that. And then we have even one more null version, which is null ptr, and this is probably the thing which we should use to indicate that this pointer is has no value right now. And null pointer means it points to, yeah, again, to a place which is null. But we will talk about this a little bit more in detail, but just so you know, all these three versions trying the same thing, make a start, initialize a start point value, which is not used, indicates this pointer is not used right now or assigned right now. All right, but in my example, I want to assign a value, and that's very interesting now. Till now we talked about variables. For example, we know we can assign a value. For example, this one says int right in front, and we know, okay, if it's an int, that gives us a hint, it must be a number, which is negative to positive in a range about 2 billions, right? And of course we can make it unsigned and signed and so on, and more options, but this is the normal way we go, right? And the same thing similar to references. No, that's not similar. Because here it says it's a int, it means more it must be a int reference, and we need here a value which is just a variable name. So that's absolute different here actually. But the important thing here is about the reference. This is just the start point, right? Remember what I mean with start point? Let me show you. Later, after I have this start point here, because it started asking for a L value, which is just a variable, for example, with a storage place, like my diagram here, only at start. But later we learned with references, my telephone number reference, I can assign later a value to it. Only not at start. Later I can. And this value here will overwrite now the referenced storage, which means both this one and this one has now both the value, this one here. That we learned when I tried to explain you, if both are using, for example, this name, variable name of my normal variable, and this referenced variable name, you see these arrows both pointing now to the same memory address, both using this one here, and this memory address has connected this value, then both have this value. But if one is able to change this value here, then both will have, the other one will have also a change value. That was here, this one. So that's okay. That we talked also. That's why I go a little bit faster over it. And now I come back to my pointer and say, what happens here? And that's also special. And why it's so special? Because this is the place where we need exactly this memory address, because the pointer here, this pointer with this asterisk here, variable says my value is not a value like this one, or a word or a character or something like that. My value is an memory address. You have to assign me a memory address. And that's so special about pointers, and that's why I try to talk so much about this memory address, because now we need this memory address. And interesting is also how we get this memory address, and I showed you this ampersand here on top with in front of a variable name. If it's not on the left side, like here it's a declaration of a reference. Now I can use this ampersand here and say address of, and then I have to specify which variable, or what you want, which address you want. I say give me this address of this my telephone number, for example. Okay, now I'm asking here special about the address of this telephone number, but not like in my diagram here with pointers. And so here it's the value, the right side, it's the value, the assignment, right? It's similar like here assign a number, which we can assign like a programmer, that's very easy. And here I assign a new number, for example, or a word. But this one is not so easy, because here we have most time no idea what the address of this variable is. And that's why we have to use this address of operator, because this address of operator will find the address of this variable name, for example this one here, and will assign it to this pointer here. So now this address operator makes sense. And you can see at start when I try to explain this ampersand a little bit, if it stands on the left side, then it's most time, for example, a declaration, not all time, but most time. And when it's on the right side, but here it can't be on the right side, but with pointer it can be on the right side, because it's explicitly, it's asking for it, right? It's asking for exactly this one. Then it's an address of operator. And interesting is this stdc out is also similar. It is here, it looks like not, it is on the right side, but here this symbol here is an overloaded operator. And when we talk a little bit deeper about how overloaded operator works, then you will see that this one is also more or less on the right side. It's not on the left side. It's not a reference. But this is a little bit special, this STC out with this overloaded operators. And yeah, let's continue here a little bit. Let's make this a little bit visual also. Let me copy this line here and paste it here. Let's see here, this one. And when I have now this variable here, let's see what happens here. I make it again very, very simplified, not too deep and not too accurate to understand it as a starter. You have, of course, read this in documentations, and pointers are a little bit more complicated than other variables, but yeah, but we will learn it. We will learn it, and we will learn on the basics. And if we understand the basics later, we will go deeper and deeper and deeper, but we try only to understand the basics. And I hope till now you know all, because what I'm trying to do now is show you how this one works behind the scene. Let's get started. So I know this is a pointer variable because I see this asterisk, not because it says a pointer variable. This is just a variable name. So we start here with a variable name, not with an address. So because here with variable, I started with the memory address, because this one is directly searching for a memory address where it will put in this value and the 4 bytes int. And here it starts again like a reference here with the variable name. Here pointer variable, and now it is asking for a value here, which is a memory address. And interesting is here, normally when I created here this, for example, my telephone number, I just said, okay, this one is connected here because this value is connected here. So I make a value place here and then I connect this one here. This asking here means like give me a memory address, which means it creates actually a arrow like this reference here. It's similar. It creates also an arrow, and I give you the memory address of my telephone number. So you can see it creates here an arrow actually and points at the point here to this memory address. And when we compare now this one, that's one reason why they say a reference behaves similar to a pointer, because yes, it creates the reference creates also a reference variable, and then it's connecting to a memory address which is fixed. Fixed means after this connection it will stay all time here. But the pointer variable, when we watch, similar, it's creating a variable point. It's called here a pointer name, a variable name, and this one is now asking here for a memory address directly. Here it was only asking at start for a location for anything which has a memory location. For example, my telephone number has a memory location. Pointer on the other side say I want anything which has directly a memory address. Right? So it's not asking for my telephone number here. It is asking only for anything which has a memory address. It can be anything what you want to assign. So, and this one is not absolutely accurate here, but it's, you see, that's enough for us. It's creating this arrow, and this arrow is a symbol of, yeah, this variable is pointing to this variable memory address, and that's why. This is one reason why they call it pointer. It has this points to a memory address. So this creation here is pointing. Interesting is this reference here on top. It creates also something like a pointer, but here we call it refers to an existing memory address. So call it not. Some call it also a pointer because yes, it makes a connection to a memory address, the reference. But it's easier to distinguish when you say here it refers, but it's to a memory address, which is just same as a pointer. The pointer variable make a connection to a memory address, and this arrow here is this connection, and they call it, pointer, and reference we call it more refer to this memory address. So I think I talked much, and the only important thing about this video is that you should understand. When you understand this reference, then you see this pointer is similar, but not same. We will talk a little bit more deep in this one. And yeah, it is just creating a pointer variable, and it is asking directly for a memory address. That's at start the more or less the main differences, but there are much more differences which we will talk in the next videos when we talk about pointers. But I think if you understand this one, that a pointer, which is here, is similar to a reference but not the same, then you understand already much, because pointer will be, let's say, when you dive a little bit deeper and deeper in it, yes, there are many things which we need to learn about pointers and working with memory address. And yes, that's also very, the most important part about pointers is really you are asking for memory addresses now. And that is so something different than a programmer, what a programmer would do. A programmer is normally don't cares about this memory addresses. This is the job of the compiler, right? The compiler, when we compile our code here, he is interested in these memory addresses because he is working literally with these memory addresses. He is changing them, assigning them, releasing them. We will see what releasing means soon, and so on. Well, normally not we, but C++ is special. In C++, you have to learn this one too. So you have to learn this kind of stuff, which leads, of course, that you have to understand also a little bit more about compiler, which leads also that you have to read much more about things which is not really related directly, let's say, to C++. What I mean with that is when you read about memory addresses, you will read more about things which is more related to hardware, how this is created behind the scene, and then you learn how C++ with pointers is interacting to this kind of stuff. And this kind of stuff you have definitely read in documentation again in good C++ books, because you see here in these videos I give you only a not absolute accurate explanation. What I mean with that, it's not the perfect definition. You will find many holes. That's normal for this basic starter tutorials, and it's anyway a practical use, not a accurate use. Accurate use means all time you are referring to the documentation and definitions in the original papers. But yes, what we want in practical is that you can use this fast, right? So as a beginner, how I create a variable, a pointer. Yes, I know. If I create a pointer, I need this asterisk here. That's the only thing which you need. The other type here is just defining, like in other variables. If you need a word, for example, you would write here a string, std string, and then this asterisk, and then this variable is same. And you need to know what this address is and how to work with that. And this was here, what we see here is just an address we are assigning in. And the interesting is here the question probably, wait a minute, we have here an assigned, and this is the value of this pointer, but what can I do with this address, right? And this kind of stuff we will talk later, because a pointer here has actually a value like this one as well. And how we get this one, I will talk in the next video. I hope you understand it so far at this point. And if not, then I would say read online documentations, good C++ bugs, and so on, because then you will probably understand it a little bit more accurate. And pointers are not so easy. So if you don't understand all things with references and pointers, don't worry. We will train it. We make right now a little bit more theory. My theory is actually very less, absolutely super less compared to that what you have to learn when you read online documentations and so. But it's enough to understand it normally. I hope so. And with that said, if you have any questions or any complaints like all time, write it in the comments and we will dive in pointers more and more. And see you in the next video, and bye.